In this video, we will be looking at the symmetric difference between two sets. So we're going to denote it by a triangle. So it's going to be A triangle B is all of A that is not B union all of B that is not A. So if we're going to represent this in terms of a Venn diagram, we have A and B. So we have all of A that's not B. So you don't want to shade anything that's B for the first set in parentheses. And in the second one, we're looking at B that is not A. So shade in all of B, but don't shade anything that's in A. So it looks, from what it looks like, it's going to be everything except the intersection and obviously the outside. So you don't want to include the outside. Okay. All right, now let's look at a couple examples. Let's say we have set A is 1, 2, 4, and 5, and B is 1, 3, 5. So the symmetric difference is everything that's in A, but not in B, union everything in B that's not in A. So what is in A that is not in B? So let's see. They both have in common a 1 and a 5. So really what this comes down to is give me all the numbers that are not the same. So ignore all the numbers that they have in common. Everything else is the symmetric difference. So you can represent it like this, which we'll just put in order as 2, 3, and 4. So that's that answer. So it actually turns out to be very simple. So let's look at another example. If I have 1, 2, 3, 1, 2, 3, I ignore all the numbers that they have in common. So the symmetric difference is just the empty set. Okay. So that one was a little tricky. Okay, the next one, we'll set A to be 2, 4, and 6, B to be 1, 3, 5. You want to ignore all the ones they have in common, which in this case, there are none. So if I look at the symmetric difference, that's just going to be the union of these two sets. So it's going to be 1, 2, 3, 4, 5, and 6. So what we can say from this problem is that if A intersect B is the empty set, that means